Hello Year 5, thank you for joining me. I want to think today about reversible and irreversible change. So I'd like you to have a think about what reversible means and what irreversible means when we talk about science. So hopefully you can see the word reverse in here. If you think about in a car, when you reverse, you're going back. So this is about reactions that cannot be reversed, cannot go back to what you had at the start. And reversible changes are things where you can go back to what you had at the beginning. The substances are the same, like evaporating water and then condensing it back into water. You still have water. A reversible change is like my match. This is a chemical reaction. I have wood at the start. After it's burned, we can see we've got soot and gas in the air. I'm now left with ash here, and I can't turn that back. Even though I'm cooling it down, I can't turn that back into wood. So that is an irreversible change, because we've got new materials and we can't get the old materials back. So I want to look at another experiment using burning, but first I'd like you to write down the science word for burning. Okay, did you remember that burning, another word for that is combustion? Okay, and what three things do we need for burning to take place? Write down the three things. And I'm going to draw them in the fire triangle. You might have come across the fire triangle before. So first of all, we need a fuel. That's the substance that's going to burn. So in this case, the wood in the matches, maybe at home on a gas cooker, if you're using natural gas. And later on, we're going to use a liquid fuel called ethanol. We also need oxygen from the air. And lastly, we need heat to get this reaction going. And with my match, the heat was provided from the friction when I rubbed the match across the side of the box. Right, I'm going to use this fuel called ethanol. It burns at a very low temperature. You can see here it is colourless and quite thin. It looks like water, but it isn't. It evaporates very easily. I can smell the fumes here. So it's quite an exciting one I've got for you here. So I'm going to pour some of the ethanol into this big water bottle. And I'm going to swish it around for a little while. I want to coat the whole of the inside of the bottle with a thin layer of ethanol. Right, now I don't want too much ethanol in there, so I'm going to pour out the excess. So now what we've got in there is just a thin layer of ethanol all round the edge of the bottle. And it's warm in the lab today, so that will start to evaporate and fill the bottle with ethanol vapour. Now for the good bit. So I'm going to dim the lights for this one. I could do the drum roll. You can give me a drum roll. Okay. Right, so take the lid off. I'm going to stand a safe distance away because it is very flammable. Okay, here we go. Okay, so when I started this, the bottle was really cold, or room temperature, but afterwards it's nice and warm. And when I do this for you in school, you'll be able to feel this as well and see it firsthand. So how do we know we had a chemical reaction? Well, we saw the light dancing around in the bottle and whooshing out of the top. I can feel heat has been given out, and I've got new materials. Well, one of these materials is in here. So I'm going to pour out what's left in here. Remember, there was no liquid left when I started the whoosh. We just had vapour. And now I have a liquid. Okay. It's colourless and transparent, just like the ethanol looked. That's over here. So how can I tell what it is? Well, I've got a quick test here. I've got some copper sulphate that you've seen before when we've done dissolving. Beautiful blue crystals. This is the hydrous form of copper sulphate with water in it. I have some white copper sulphate here. It's anhydrous. That means it doesn't have any water. So if this liquid here is water, when I add it, it should turn the copper sulphate this beautiful blue colour. I'm going to just separate some of this off for our This is the one that came out of the bottle. Okay, it's going that blue colour, so that tells me that water is present. So one of the products, one of the new materials was water. Just compare that to the ethanol. Okay, it's not changing. Staying white and pale. So this tells us that this is not water. Okay, I'd like you to try and find out what other materials are made when you have a reaction like combustion. Thanks for joining me, and I'll post you some more videos later. Bye.